Hi, welcome to MACSGATE. Today we are starting a new course, DBMS. In this session, I will give introduction about DBMS. What are the advantages of DBMS or why we need to use DBMS? So let us start the session. DBMS. So before going to the definition of DBMS, let me define the small definitions about data. A data can be in so many formats. So the regular formats which we already know is it can be a textual data or it can be in audio format or it can be in video format. And we collect the data or we store the data about different resources. Suppose I can have data about railways or I can have data about my students or I can have the data about the courses which I am discussing on YouTube. So this is about data. Then what is database? What is a database? A collection of related data. So database is a collection of related data. That means the collection of data which is about a particular resources. So collection of related data. Suppose in a hard disk, I store the details of all my students. Then that is called student database. Then that is called student database. Like that, we can have so many databases. Then what is DBMS? What is DBMS? It is a software. It is a software which can be used to manage or access the data in the database. So a software which can be used, a software which can be used to manage or access the data in database. So suppose this is the user, or let us suppose that we are the user and I want to communicate with the database. Communicate in the sense we need to access the data in the database. So instead of directly communicating with the database, we use a software which is DBMS. Now the question is, why we need to use this DBMS? Why don't we communicate with the database directly? If we use DBMS to communicate, we are having so many advantages. So what are the advantages of using DBMS? That is what we are going to discuss in this session. So before going to DBMS, let me introduce the file system, which we are already using in our regular life, or the system which we use to store the data in our personal computers or laptops or desktops. So file system is where the files or the data is managed by operating system. So in file system, who will manage the files are? So it will be managed by the operating system. Then when the files can be managed by operating system, why we need to go to another software, DBMS? Because there are some limitations when we use file system, or there are some problems which can be raised when we operate the files by using file system. So the main thing is, what are the limitations or the problems with the file system? That we need to know. Then whenever I have a problem or limitation, how it can be overcome by using DBMS. So what are the techniques or advantages? What are the techniques or we can say the advantages of using DBMS? to overcome the problems which were raised when we use the file system. So let us discuss those problems or advantages of DBMS one by one. So limitation, advantage. My intention is what is the problem we face when we use file system, and what is the technique which we are having in DBMS to overcome the particular problem. This is my introduction. Sorry, this is my intention. So let us discuss each of these limitations one by one. The first one, difficult to access required data. In regular file system, suppose I want to access the details of a student Sudhakar, then I need to know the storage details of the particular data. So what is meant by storage details? First of all, I should know what is the file name in which I have the details of Sudhakar. Without knowing file name, I cannot access the data of Sudhakar. The next one is the location of the file or path of the file. Location or path of the file where it was saved. Then what is the format of the file? Depending on the format of the file, I need to use appropriate software to open that file. Format of file. Like this, we need to know the storage details of the files where my required data is stored. If I have very small amount of data, we may remember or we can remember the storage details of all the files. But this is not suitable. This is not suitable or not feasible for large data. So whenever my database is very large, I cannot remember the storage details of each and every file. So this is the first problem which we are having when we are using the file system. Then how we can overcome this problem when we use DBMS? For that, we are having a technique which is called data independence. So let me give a brief introduction about data independence. So in DBMS, the levels of access is mainly divided into three parts or three levels. In first level, we are having different schemas which are called external schemas. For the same database, we can have so many different schemas depending on different groups of users which are intended to use the same database. I may have one external schema. This is my first external schema. This is my second external schema. This is my third external schema. Something like we can say different views with which the users can access the data. All these schemas or views are connected to logical level or logical schema. What is logical schema or what is the responsibility of the logical schema? In a logical schema, we define what is the table name and what are the attribute names, what is the type of the data which we are storing in that particular table. So we give the details of the data. We give the details of the data, what to be stored. So logical schema is mainly responsible to give the details of the data, what to be stored in my database. To use the particular database, the customers or the clients no need to know about logical schema. Directly by using the interface, they can access whatever they require. So that is called logical independence. So to access a particular data about the resource, no need to know the logical schema of the data. Suppose I want to access the details of Tamil Nadu Express. No need to know how the details of the train were saved in the database. Without knowing all those details, we can access the details of Tamil Nadu Express, which is called logical independence. Then it will communicate with the next one, which is physical schema. Which is physical schema or physical level. What is the responsibility of the physical schema? It decides how to store the data in the hard disk. How to store the data in the hard disk. How to store in the sense, what is the data structure we need to use to store the data to provide efficient access. So it is mainly responsible how to store the data in the hard disk. This logical schema don't mind about the physical details, how the data is stored. Even the physical schema don't know how the table is having the data types and all those details, which is called physical independence. So this is about the data independence. Whenever I want to access a particular data, no need to know the storage details of the particular data or the file in which my data is stored. So this technique is called data independence. The next one is more access cost. Suppose I want to access the details of a student Sudhakar. I want to know the details of a particular student Sudhakar. Let us suppose we are having a student database. We are having a student database. This is our database. Let us suppose it is of almost 10 GB. Now, if I want to access the details of the student Sudhakar, first of all, we need to bring the entire 10 GB data to main memory. I need to bring the entire data to main memory, which is very costly to bring all those pages or blocks from the secondary device to main memory. Then only I can access by using main memory. But instead of that one, if we use DBMS, we are having a concept of indexing. So the indexing will mainly give the details of the file where the details of the Sudhakar were saved. So by using index table, we can get the details of the file. We can get the details of the file where my required data is present. Whenever I know the details of the file, I can bring only that particular file from secondary storage to the main memory, which will save so much amount of time. So we will discuss the details of indexing in more detail in upcoming sessions. The next one is less degree of concurrency. What is degree of concurrency? The number of users who can use the data simultaneously. The number of users who can use the data simultaneously. Suppose we are maintaining the data about reservations. We are maintaining the data about reservations. And let us suppose I have two files. I have two files. In first file, I maintain the details of reservations from Vijayawada to Hyderabad. In second file, I maintain the details from Vijayawada to New Delhi. Suppose now a user wants to do some reservation from Vijayawada to Hyderabad. Then he will use file 1. He will use file 1 to do the reservation, or we will update on behalf of the user about the particular reservation details. Now at the same time, if another user also wants to do the reservation from Vijayawada to Hyderabad, he need to wait till the completion of the reservation of the first user. At the same time, two users cannot access the same file. Of course, if the user wants to access or he wants to reserve the ticket from Vijayawada to Delhi, he can use the second file. That means two users can use two different files at the same time, but two users cannot use the same file at the same time. So here the first one, level of concurrency. Level of concurrency. This is only up to file level. That means different users can use different files at the same time, but different users cannot use the same file at the same time. And the degree of concurrency, that is the number of users who can use the data, is very less, since the concurrency level is only up to files. Now, if we use DBMS, we are having concurrency control schemas with which we can maintain concurrency level at record levels. At record levels. That means in the same file, if one user is accessing or updating the first record, another user can access or update the next record or another record. That means two or more users are allowed to use the same file. One person is working on first record, the second person may work on 10th record or 20th record. But two users are not allowed to access on the same record. So that is the meaning of record level. So the concurrency or the degree of concurrency is very high, when we use DBMS. We are having so many concurrency control schemas. We will discuss all those details. The next one, difficult to implement different levels of access control. Difficult to implement different levels of access control. Suppose, let me give the example of student database. So let us suppose that we have a details of students. Okay. Now let us suppose that I have two users. One is faculty. The second one is administration staff or HR staff. As a faculty, the faculty need to access only some particular part of data. The percentage of students, the previous backlogs of students, or the intermediate rank, or the previous percentages. Like that, he need to access only some part of data. As a administration section, he may not need the percentage details or something else. So he may need some other details. So he may need some other details, or the administration section may need to access all the details. Okay. So in general, the administration staff will have to access all the details of the students. So here I save the data which the faculty is supposed to use, and I will save the data which the administration section supposed to use. That means I am maintaining the same data in multiple copies. We are maintaining the same data in multiple copies. If I have only two types of users, it may be possible or feasible to maintain two copies of data. Suppose I am having 10 different types of users. Then can we maintain 10 multiple copies? It is a loss of wastage of storage. And for every user, we need to decide what are the parts of data they need to access. Like that, we need to separate the data physically. Okay? In real time, it may not be appropriate or feasible. Then, what is the technique to overcome this problem? For that, we are having a concept of views. So, in views, we will have the same database. For example, suppose take railways. If I log in as an ordinary user, the view is different. Suppose if I log in as a railway employee, the view may be different, or he may have some more extra access or some more extra information. Instead of that one, suppose I am logging in as a railway minister. Then the view is different and I may have some other access controls. So depending on the different types of users, we can maintain different views. All these views were logically implemented. Logically implemented means we are having the same database. That means we are maintaining only one copy of the database. But we create different views depending on the different types of groups who are intended to use the database. Is it clear, sir? The next one, atomicity problems. These atomicity problems we discuss in more details in upcoming chapters. So let me give a small example of atomicity problem. Suppose I want to withdraw cash from ATM. So you want to withdraw cash from ATM. When we insert the card from the ATM, when we enter the amount, then suppose the first step is it will verify the balance of my account. If I have sufficient balance, money will be debited from my account. Then cash will be dispensed. So in my transaction, I have two levels or two parts. Suppose the user entered the amount whatever he wants, money debited from the account, this was done, and he got the cash. So the transaction completed 100%. Then the user don't have any problem. He is happy. Suppose the user started the transaction. Suddenly the technical problem rises. So money is not debited and cash was not dispensed. Then also no issue. But suppose there is one situation where money debited. After that particular point of time, some technical problem rises. So cash is not dispensed from the ATM machine. Then the customer is in problem. So every transaction, either it should be completed 100% or it should be completed 0%. So atomicity problem we can say simply 0% or 100%. In atomicity problems, we are having mainly four types of problems, which are generally called acid properties. Among those acid properties, the first one is atomicity, which we discussed just now. The second one is consistency. When so many users are accessing the data simultaneously, the problem of inconsistency rises. And isolation. Whenever multiple users are accessing the same data, we need to create an environment in which the client feels that he is the only person who is accessing the data, or the actions of other users should not interrupt this user. That is called isolation. And the next one is durability. Whatever the changes we have done, those changes should be forever in the database. That is called durability. So these are the problems which we are having when we use file system. Then to overcome these atomicity problems, we are having transaction management. So in this, we are having so many protocols. So this transaction management is responsible to overcome atomicity problems. The next one is redundancy. In simple words, redundancy means duplication or multiple copies of the same data. Multiple copies of the same data. With redundancy, two major problems are, the first one is wastage of memory. The second one is normalization. Sorry. The second one is inconsistent data. Inconsistent data. So to overcome these two problems, we apply normalization techniques. We apply normalization techniques to overcome the problems of redundancy. We discuss all these topics in details in upcoming sections. Don't worry about it, sir. So as of now, let us assume normalization is a technique which will be used to overcome the problems of redundancy. So the next one is RDBMS. In our course, we mainly discussed about the details of RDBMS. Sir, there are so many types of DBMS. That means there are so many types of softwares to deal with the different types of database. We mainly focus on RDBMS. What is RDBMS? Relational database management system. Relational database management system. What does it mean? The software which we use to manage relational database. The software which we use to maintain or to manage relational database. Automatically, what is our next question? What is relational database? A database in which data is stored in the form of relation. Data is stored in the form of relations. What is meant by relation? In general English, a relation is a table. So, a database in which we maintain or we store the details in the form of tables is called relational database. And the software which we use to manage relational database is called RDBMS. We are having so many providers which will provide the softwares of RDBMS. These are some of the examples of the softwares and the corresponding authorities which provides those softwares. Just go through it, sir. Among all these, we are familiar with these two, MySQL software and Oracle DBMS software. When coming to first one, this is free. For our practice purpose or to practice the questions in DBMS and to practice SQL, we can install this MySQL on our personal computers. But to use Oracle DBMS, we need to maintain client-server architecture. So it's my suggestion that to install MySQL to practice the concepts of DBMS and SQL. In next session, we will see the details of relational model. What are the technical details of relational model or how to store the data in relational model database. Thank you.